Okay, this lesson is 11.4 Common Logarithms. We are going to be specifically discussing the logarithm function that is built into your calculator, which is log base 10. So our common logarithm has the base of 10. So we have been dealing with logarithms with other bases, but today we'll be specifically dealing with when we have a base 10 function. So y equals log base 10. So on your calculators, that log function has a base 10. So if you take a look at a calculator, down here you see that log function that has a base of 10. All right, so we are going to solve these. The way how we're going to solve these is we're going to use our properties of logarithms that we learned the previous day. So what we know about exponents in logarithms is that when you have an exponent on a logarithm, you end up multiplying by that exponent. So what we can do to solve these problems when we have a variable in our exponent is we can take the log of both sides. So I can take the log of 3 to the x and make that equal to the log of 10. Now when we just write log, that is telling us that the base number is 10 there. So when we only write the logarithm, it's telling us that the base number is 10. So now what I can do is the x in the exponent can drop down in front. So that's the same thing as x times the log of 3 is equal to the log of 10. And then to get the x alone, we can divide by the log of 3. Okay, now you'll be able to do this in your calculators. Most of you, when you open up the log function, it puts a parentheses on. Make sure that you close that parentheses before you hit the divide by button. So here, I'm going to take the log of 10 first. So there I took the log of 10, and now I'm going to divide by the log of 3. And here I get this whole string of numbers, and we're going to go to the nearest 4 decimal places. So 2.0959. Okay, so once again, to get that answer, we had to take the log of 10, and then we had to divide it by the log of 3. And when we actually divide that out, we get our 2.0959 for our final answer. Okay, let's move on then to our second example. Our second example, we have 5 to the x is equal to 62. So we're going to solve these the same exact way by doing the log of both sides. Now, a question that might arise here is why aren't we solving these equations like we did earlier in this unit, where we looked at each number and we tried to break it down as far as we can. Well, here we have 5 to the x, but 62 in no way can be written to 5 to some power. It's just not going to happen. So when we aren't able to write both of our numbers with the same base number, that's when logarithms are going to come into play. So here we'll start by taking the log of both sides. So we'll have log. So we will have log base 10 of 5 to the x power is equal to log base 10 of 62. We know that our exponents can be dropped down in front and multiplied. So this is the same as x times the log of 5 is equal to the log of 62. And now to get our x alone, we will just divide both sides by the log of 5. So once again, you'll have to grab your calculators out to solve this. So this time, I'm taking the log of 62. I am dividing it by the log of 5. And we get 2.5643. So there's our final solution. All right, moving on to some other types of problems. This is the same idea, except for now both sides of the equation have an exponent. So we're going to have to use our properties of logarithms on both sides. So here, we'll take log base 10 of 2 to the 7x is greater than log base 10 of 3 to the 5x minus 3. Now we will use our properties of logarithms to take each exponent and multiply it out in front. So this is really 7x times the log of 2, which is greater than 5x minus 3 times the log of 3. Now if you notice here, we have x's on both sides of the equation. So in order for us to get our x alone, we definitely have to move our x's onto one side. So we'll start by distributing our log of 3 throughout those parentheses. So then we have 7x log of 2 is greater than 5x log of 3 minus 3 log of 3. Now to get our x's on the same side, we'll have to subtract our 5x log of 3 over. So we will have 7x log of 2 minus 5x log of 3 is greater than negative 3 log of 3. Now notice here we have x's in two locations and we do not have like terms because they're different logs. The first one is a log of 2, the second one's a log of 3. So what we can do is we can take that x out. So we'd have x times 7 log of 2 minus 5 log of 3 should be greater than negative 3 log of 3. And then finally, to get our x alone, we can divide both sides by that 7 log of 2 minus 5 log of 3. You, of course, could use your properties of logarithms here to rewrite this in a little bit simpler form if you would like to. And I'll show you that in just a minute. Okay, so you could certainly put this whole string into your calculator. Make sure you divide by and you include parentheses around that whole string. Your other option is that the 7 and the 5 are in front, so that means that those are exponents. So this is really log of 2 to the 7th minus log of 3 to the 5th. And then our properties of logarithms tell us that when we subtract, we are really dividing. So this is really log of 2 to the 7th divided by 3 to the 5th. So you also could divide both sides by that value as well. It doesn't matter which way you do it, you're going to end up getting the same exact answer. So we're going to put this into the calculator now and see what we get. So we have a negative 3 times, I've got a 0 in there, hold on. Got a negative 3 times our log of 3. Okay, when I just take negative 3 times log of 3, I get this. And then we want to divide by, using parentheses, 7 times the log of 2 minus 5 times the log of 3, close your parentheses, equals. So this answer is 5.1415. That's what your x value is equal to. Now this is obviously a more challenging type of problem than what you would see. But you should be able to do it. And once again, you could have divided by 2 to the 7th divided by 3 to the 5th as well, your log of that. And you would have still gotten 5.1415. You still got the same exact answer. All right, so I'm a little bit out of space on this slide. So let me get that other problem onto a new slide. There we go. So let's try this problem. 7 to the t minus 2 is equal to 5 to the t. And once again, we're going to start off by taking the common logarithm of log base 10 on both sides. So we'll have log of 7 to the t minus 2 is equal to log of 5 to the t. Each of our exponents, we're going to use our properties of exponents, and we're going to bring those exponents down out in front. So here we will have t minus 2 times the log of 7 is equal to t times the log of 5. And then we will distribute our log of 7. So we'll have t times the log of 7 minus 2 times the log of 7 is equal to t times the log of 5. And now if you notice, our t's are on both sides of the equation. We need to get them on one side. So we will subtract both sides by the t log of 7, which leaves us with negative 2 log of 7 is equal to t log of 5 minus t log of 7. Log of 5 and log of 7 are not alike where we can combine them, so we're going to take a GCF of a t out. So our negative 2 log of 7 stays. This is equal to t, and then in parentheses, log of 5 minus log of 7. Now to get the t alone, we can just divide by log of 5 minus log of 7. Remember, if you leave it like this, use parentheses in your calculator. The other option here, since we're subtracting these two logs, it would also be the same as dividing by log of 5/7. Does not matter which way you go about it. So using your calculator, you start off with negative 2 times the log of 7. And then you have to divide that by, in parentheses, the log of 5. Oh, I made a mistake, so I'm going to go again. So negative 2 times the log of 7 divided by the log of 5 minus the log of 7. Close your parentheses, equals. So for this case, we get t to be 11.5665. Okay. I just realized on this previous example we had a greater than sign, and in our solution we did not include that greater than sign. We do want to make sure that we keep those signs. We also want to make sure that when we divide, if we ever are dividing by a negative number, that we make sure we flip the sign. So here, when we figured out that denominator, so when we figured out that denominator of 7 times the log of 2 minus 5 times the log of 3, when we got this denominator, we have a negative number. So we divided by a negative number, so we would want to make sure we flipped that sign So we'd say x is less than 5.1415. And something went very wrong with that marker, so let me just rewrite that so it looks a little bit neater there. So we then got x is less than 5.1415. Take 4 on writing this out correctly. What is going on here? X is less than 5.1415. There we go. Okay, we're going to do one more example together. That is this one. 4 to the p minus 1 is less than or equal to 3 to the p. So once again, we want to keep the inequality signs throughout. And we're going to take the log of both sides. So we will take log of 4 to the p minus 1 is less than or equal to log of 3 to the p. Our properties of logarithms says that if we have an exponent, we can multiply it out in front. So this is the same as p minus 1 times the log of 4 is less than or equal to p times the log of 3. Now, we can distribute our log of 4 throughout the parentheses. So we would have p times the log of 4 minus 1 times the log of 4, or just minus the log of 4, is less than or equal to p log of 3. We need to get our p's on the same side, so we will subtract our p log of 4 over. So we will be left with a negative log of 4 is less than or equal to p log of 3 minus p log of 4. We need the p alone, so we can take the greatest common factor of the p out. So we are left with negative log of 4 is less than or equal to p times the log of 3 minus the log of 4. Now to get the p alone, we can divide by the log of 3 minus the log of 4. And make sure you include parentheses around the whole thing in your calculators, or that'd be the same thing as dividing by the log of 3/4. It doesn't matter which way you do it. So here we'll get the calculator out. So we had the log of 4 negative. That's a negative number right there. So now when we divide, we want to see if we're dividing by a negative. So we will now divide by, in parentheses, the log of 3 minus the log of 4 close your parentheses. That is a negative number that we're dividing by, so we're going to have to switch our signs. So we get 4.8188. We had to switch the sign so it's greater than or equal to p. Writing so that p is first, we'd say p is less than or equal to 4.8188. So there is common logarithms.